Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, everyone. Welcome back to another exciting edition of IT Pro TV. I'm your host, Vaughn Smith, and this is Cisco CCNA for exam 200-301. We are going through our networking topology architecture section, and now we're going to take a look at WAN. And here he is, Mr. Ronnie Wong. How's it going?
Vaughn, it is going very well as we begin this particular episode. Hope you are doing well too.
I am.
All right. So here it is. We are ready to jump into, some of these other particular topologies that we need to learn about as well. So what we want to do, of course, is make sure that as you are someone that's beginning maybe your career in terms of being a CCNA professional, the very fact is that we all have to encounter some of these technologies. Now, when I first began doing this, Vaughn, I was fairly good at the idea of the LAN side, right? The local area network. I understood the switching. I understood, the idea of actually going out to a gateway. Everything was fine. Once I got past that point, though, Vaughn, a lot of it became more mysterious. I knew we could connect to the internet because we were able to do so, but anything past that, though, all of a sudden became more mysterious in that sense. Now, it doesn't mean that I didn't know that there were technologies out there, but as far as just really understanding, because we don't really get to put our hands on how this stuff works, okay? So we just kind of, at least at the beginning of our careers, assume that they're out there and that they actually have to work in some way and somehow. We just go, it doesn't matter because I'm not going to ever be responsible for that. But the very fact is, you may end up getting hired in this situation where you have to understand at least those connections. The reason why is networks have expanded beyond the idea of a single office anymore. So it might be where your company actually has multiple offices as well, and you have to understand the technology that's being used in between. So a great example, Vaughn, for us as we begin is to think about, right here at IT Pro TV. The very fact is, Vaughn, we not only have our, main office right here in Gainesville, Florida, where we're actually shooting from today, but we also have the UK office, Vaughn, right? Okay?
We do.
Yeah, and that UK office.
Chichester.
Chichester.
I think we're all saying it wrong.
Yeah.
But
Yeah, for those of you in the UK, my apologies for the way that we actually are butchering that particular name there. But just kind of realize, yes, we actually have another office out there. Now, there's many different ways that we can connect. At the beginning, I always thought it was just the internet. There's actually a lot of different technologies that we can make that type of connection through. We need to understand some of those topologies, some of those technologies. So we'll actually be talking about those as well. But on top of that, though, Vaughn, once we actually decide on what particular type of technology that we're going to use, which I've got to make sure I say right. Technology and topology seems to kind of almost tongue twist me there. But the very fact is, once we decide on that, we now have to think about the idea of the topology that we're going to use in between something like that as well. So in that sense, we need to have a good understanding of not only at least the basics of the technology, but also the type of topology, because that can come into cost in terms of play and configuration if we actually need to get things set up. So, Vaughn, let's go ahead and dive in, and we'll start talking about the idea of some topology right away. So, Vaughn, I'm going to let's go ahead and take a look at my screen, and that will kind of help us out. Now, Vaughn, we're going to start actually from the close side of things. And that, what I mean by that is, let's start not actually going into the WAN technology itself, but let's start off by actually doing and trying to take a look at what we are fairly familiar with, which is internally. So, Vaughn, normally inside of a particular, local area network, for us to get out to the internet, or, we're actually going to go through a service provider, which I've actually listed right here as an ISP, internet type of service provider, whether it's actually one or two, it doesn't really matter. But there's a couple of different things that we need to know. And what we're taking a look at is what we call single-homed or dual-homed type of topologies that are out there. So, for example, let's say that our UK office that's out there in Chichester, UK, what they have is what we call a single-homed type of connection out to whatever their service provider is going to be. Now, you can see very clearly that the idea of single-homed is fairly simple here. Our UK office's particular router, they're going to connect out through a single link out to their single ISP, which is perfectly fine. It's not our largest office. Our larger office is right here in Gainesville, but it actually gives them that connection that they need. And as long as I only need the connection, I'm not worried about anything else at this point, then that idea of doing a single home connection, one, is cheaper, okay? Two, the other fact is it actually provides for us what we need to be able to do, which is normally connect out to some type of service provider as well. So the UK office, at least in this particular topology, which we tend to see here, looks like a point-to-point type of connection, which we'll talk about in a moment. We'll actually end up seeing that too. Now, Vaughn, the other one that we have is also known as dual home. Now, you might see this in two different configurations, though, Vaughn. Where you might see this is kind of a little bit strange here, okay? So you might see where it's actually a single router, like over on the left-hand side, where that might be GNV Office, but then you might have ISP1 and ISP2 over here on this side. That's a little bit different in that sense. But when we talk about the idea of a dual-homed connection out to our WAN, our wide area network provider, what we're saying is that in our Gainesville office, we have two separate router connections, and that they are both going to lead out to the ISP. Vaughn, this not only provides for us the connectivity that we need so that we can get out on the internet, or even to communicate with the US for the UK office here, but it also means that if one of these routers fail, so let's say that the top router fails, then I still have the connection that I can go through the bottom router. Or if one of the links fails, the other one can actually take over and we can still do that. So it provides for us that redundancy that we need. Dual home is probably a more preferred type of connection if your business requires something like this as well. So for us here at IT Pro TV, Vaughn, what we want to do is we want to ensure, as we're doing right now in live streaming, that even if one of our routers internally fails, the other one can actually pick up and we can still continue to stream and do that. So we've got our networking equipment and our router configuration done exactly in this one, which we call a dual home configuration. And we even have another aspect that we're actually having a second ISP where both of them are actually connected that way too. So it actually does allow us something else, but that's a little bit more technical than what we're actually getting into. So at this point here, this is what we want to at least understand. So one is, of course, for redundancy and failover, just in case the other one fails. The other one just provides for us the connectivity that we need. Now, understanding that, Vaughn, we actually also can see that this is a little bit of a different configuration depending on what we actually need to talk about too. So, Vaughn, we need to go back to the basics that we might have learned about maybe in our previous CCENT studies for those that were taking a look at earning your Cisco certified entry-level network technician in the previous iteration of the exam, or maybe in the CompTIA Network Plus, where you learned about some of these different topologies. But we're just going to do a brief overview of some of these different topologies that we need to talk about. So let me scroll back up to this point and we'll see this, okay? So, Vaughn, a very typical type of topology that we can actually think about here is the idea of what we call a point-to-point connection, okay? Now, when we start talking about the idea of a point-to-point connection, this can actually be done over many different types of technologies that we can talk about. But it's exactly like it sounds about. So the very fact is, in my main office, when we connect through whatever the actual technology is, okay, then the branch office sees it as being really that only one connection, hence point-to-point. There is no other network that it sees in between me and the branch office and the main office here, okay? So that is a very popular connection. It's actually been very popular for a long time. So in this particular type of connection, when you start seeing this, the different technologies that are involved, and we'll talk about these as we go along a little bit more. In the oldest rendition of this, the most expensive rendition of this is what we call privately leased lines, okay? Now, privately leased lines, it's exactly like it sounds like. You go through maybe your service provider and you say, hey, I need a private lease line between branch office and main office. It is like us actually running a direct cable from my main office router over here all the way over to the UK into our Chichester office. And when we do that, it's literally like we plug the cable in on the router over in the Chichester office. And we're leaving that connection up and running. Now, Vaughn, from Florida all the way over there, that's quite a long distance to be able to do so. So that actually costs quite a bit of money. Secondly, nobody else is sharing that particular connection. So, Vaughn, that means I'm paying for the entire link as I do this, okay? But the advantage is it's completely private. It is our particular link to do with as we choose to. So whether we use it or whether we don't use it, we're actually the ones on the hook for it.
Kind of sounds like, is that going to be expensive?
Very expensive.
Yeah. And so you would need a very, very large organization possibly to be able to afford that, or even like for us, that would be like way too much.
Yeah.
We don't need it. We're a smaller organization as opposed to like a much larger organization with tons more traffic going through it.
Yeah, well, again, it can be just because of cost that we don't need it, but it also depends on the industry that you're working in. You might find out in whatever industry you're working in, it requires a completely 100% private type of connection. Well, if they say you can't use anything else but a leased line, well, then you have compliance issues that you may have to deal with and still do this. So it's very possible that regardless of the cost, you still have to do it.
But I think you just hit a point that I didn't even think about, the privacy of it.
Right.
Yes. Okay. So that
there's
might
reasons
be,
for it.
sounds like more reasons of like comparing and contrasting. I always try to think about these in like what the exam might be quizzing me on,
Sure.
or like why I would need to know about these things and like the different aspects of why you would want to choose one over the other
Right.
for certain scenarios.
Sure. All right, so let's go ahead and take a look at another particular topology that we want to get familiar with as well. And then we'll also talk about another one of these too, because all of these can be implemented in this way, somehow. So Vaughn, we'll move on to our second topology here. And this one is fairly simple as well, depending on how we choose to do this. Okay. So Vaughn, a fairly more popular type of topology that helps us out is what we call the hub and spoke topology as well. Okay. Now the hub and spoke, notice that we don't have direct connections between the UK office, the Chicago office, and the North Carolina office here, okay? But look at those connections that we have. Going across whatever cloud provider that we have, whatever WAN service provider or internet service provider that we have, notice that all those connections go through what? The GNV office, okay? So Vaughn, that means if we're in the UK office and we need to communicate with the Chicago office, guess what? We have to go from the UK office, and it gets routed here at the hub, and then sent back out the second spoke so that data can actually go through and get connected there. Okay. Now that particular type of connection can be done. It can be done over privately leased lines, but a lot of times what we might end up seeing that it's done something like over MPLS lines too. Okay. MPLS is multi-protocol label switching, and it's a private service that's actually out there. And what this gives us the advantage to do, though, Vaughn, and this is why I chose MPLS to help us describe this as well, is that we can use this even in the former one, in the point-to-point. Vaughn, believe it or not, hub and spoke can actually be done in a couple of different ways. Okay. So, Vaughn, I can create a point-to-point connection just between UK office and GNV office. I can create another one between the Chicago office and the GNV office. And I can create another one between the North Carolina office and the GNV office. So I can have 3 different point-to-point connections if I chose to. So it's very possible that I can do that. Or I can do what's called a point-to-multi-point here, where it actually is essentially, when we actually make those connections, it actually does see this as being one big network. Okay. So we can actually do it that way instead. This is a single point, but actually goes out to multiple points here. So this can actually be sharing one big private IP address range if we wanted to, or whatever range that they give us. We can actually have them all looking like that they're directly connected to a switch. Slower, but it can actually be that way. The advantage of MPLS, multi-protocol label switching, which is very neat, at least in what I think about here, Vaughn, is the very fact is it doesn't matter what the technology is running on each end of this, okay? And what that means is I don't have to reconfigure anything. MPLS says I can take whatever layer 2 technology is actually on either side, and I can make that work, and it doesn't really matter. So it allows us to actually say diverse different network types that may be out there. The MPLS essentially strips all that, no, I shouldn't say strips, encodes that or encapsulates that inside of what we call label switching, okay? The advantage of this is very quick and very fast, because we're no longer using just IP. We can encode IP, okay? We can actually do that, but we actually apply another label to it. So Vaughn, the neat thing about the idea of what MPLS actually allows us to also do is that it actually allows us to be able to provide an additional label, and then after the first edge router that actually applies the label, then everything else, once it actually gets all the ones that it needs to, it doesn't have to do it throughout all the other devices that are actually in here. Every other device will just simply read the label and know exactly what to do with it, is what it will actually end up doing. That's the advantage of using something like MPLS. So this is a very popular type of provider that we can do. Now, Vaughn, the other thing, notice that I also put down here is internet. Okay, so I said some type of WAN provider or internet. Now, if I choose to use the internet connection, can I still do something like this? Yes, okay. But if you do something like this, you actually make 3 point-to-points. And instead, you'll be using what we call different types of VPN connections. So the most traditional one here is going to be using that virtual private network by actually linking our GNV office over to the UK office, over to the Chicago office, over to the New York office as well. And we'll actually do site-to-site VPN connections that will look like privately leased lines, even across the public internet that's actually out there. So this is by far the cheaper option that we have. Provides about the same level of privacy that we normally would see as well, but much more cost effective. And so people like using this. Now, the drawback of doing it over the internet, okay, Vaughn, sometimes we actually have to realize something, that the internet, it works great. We love it. We use it every single day. But the very fact is, there can be outages along the internet path too. Things can slow down on certain places that we didn't expect them to slow down on. We've had where we had DNS segmentations happen. Well, it's fine as long as you were sending data east and west, but trying to go north-south, it didn't work as well. So you have to kind of deal with whatever the actual issue of the day may turn out to be, where there's slowdowns along the path. As long as you don't worry about stuff like that, then you're perfectly fine and able to handle that as well and actually save a ton of money by using something like this too. Okay, so that is another possibility out there for us. All right, let's talk about at least one more here is what we'll do. And actually both of the last, the idea of Metro Ethernet and even the idea of broadband point-to-point over Ethernet, we can also see right here as well. Now, this one we call full mesh, and that's because the entire cloud really looks like one big network here. Metro Ethernet is actually pretty good. Now, we don't tend to see this in the scale that I have here, which is across multiple continents and everything, but Metro Ethernet is designed to essentially change everything to just about working exactly like Ethernet does. So it looks like an entire layer 2 technology as well. But MPLS can actually be run over this. Broadband point-to-point over Ethernet can also be run in this particular type of configuration as well. You name it, all those are actually good and provide for us what we actually need here. Now, the idea of the Metro Ethernet, usually again like in a metropolitan area, much smaller scale here, but I just kind of forgot to change the labels when we started doing this, but you kind of get the idea that it allows for those connections to be worked, and you don't have to worry about what the actual underlying technology is. It's very simple and easy because it works like your LAN does internally, and you just connect in using that, their service provider too. Broadband broadband point-to-point over Ethernet. This one is actually designed for a specific purpose, Vaughn. If we're using cable internet access, okay, that's kind of the big one that we have. They provide for us broadband type of internet connection, okay? Now, on this one, I'll have a particular slide for it that I remember, yeah. So, in the idea of the broadband point-to-point over Ethernet here, cable internet access is actually fairly kind of a neat thing. The very fact is, you move into a neighborhood, everybody essentially goes to the cable provider because they run cable into your home. But remember that you're sharing that cable is what you're doing. You're sharing that particular type of connection and getting everything done the way that you want to. But there's slowdowns, aren't there? Okay, so sometimes in the morning, you're probably go, man, this is lightning fast. You come home in the evening, you sit down at Netflix, and all of a sudden, it's not as fast as you thought it was going to be. That's because everybody at home is watching the same Netflix series that you are. That's because you're sharing that particular type of connection to do so. Now, the way that this actually, works here is simple. They have to be able to keep track of who's connecting where. So by doing this, broadband point-to-point over Ethernet allows us to create the idea of a point-to-point connection, even though it looks like that we're connected to a switch here. So it provides for us authentication is what it does. So it gives us the ability to now track, even if Vaughn lives on the same street that I do, we can actually authenticate the actual modem itself, verify that everything's actually working or the router is working, everything's actually doing what it needs to. So all these are pretty much the different types of topologies as well as technologies, and we should at least have a fundamental understanding of it. Now, we're not going super in-depth into any one of these. The reason why is now at the Cisco level, right? A lot of these, if you want to learn more about the WAN technologies, you'll find them inside of the specialization type certification that you're actually looking for in the newer Cisco next level certifications. So we're just making sure that you at least have an understanding, a very broad level understanding of everything that's there. But I challenge you to actually kind of find a little bit more information on your own. But we're just introducing this topic, at least at this point. Maybe a little bit later on, we'll actually see where it might affect us as we actually get into jobs more along the ISP side, more along the WAN provider side. You got to understand that technology, and you actually get that more in that particular space and era than what we will here, which is just introducing those topics. So as long as we can identify the point-to-points, the idea of the hub and spoke, the full mesh topologies, understand the dual-homed, single-homed environment, and the different types of WAN technologies that can run over all those different things, the way that they're configured, we'll probably have a good understanding of what we need, not only for the exam, but at least be able to have a conversation so that somebody can understand what we're talking about and that we can understand what they're talking about as well. So, Vaughn, that's where we'll actually leave it at this point.
All right. Always great words of wisdom. And I know I've been in plenty of different lectures where I might know A and B, but maybe not C so much. So, definitely go out and supplement your information, do some searches and read some different other materials, because I know that helps me. So just wanted to pass that along to you as well. Thank you, Ronnie. Thank you out there for watching, but we're going to go ahead and sign off for IT Pro TV. I've been your host, Fawn Smith.
And I'm Ronnie Wong.
We will see you soon.
Thank you for watching IT Pro TV.